So today my topic is Seaborn. So on Seaborn we have to install all the necessary things, which is import pandas as PD and matplotlib, and following by Seaborn as SNS. Next I'm going to install my Seaborn, like pip install Seaborn. And next I'm going to load my data set here, that is a data set which is equal to pd.read csv, which is my csv file tips which have been downloaded from the online. And next data set dot head. So head is nothing but which prints the first random numbers, which is top of the csv file, which prints the top of the numbers. Likewise the tail, which prints the last from the csv file. Like if I'm giving the random numbers like 2, head dot 2 means it gives me a random of 0 and 1 index. See, so my 0 and 1 index have been shown here. If I'm giving as last 4 something, it gives me the last 4 tails like 240, 241, 242 and 243. Next, dataset.info. So info is nothing but getting the information about the dataset. So that is about the CSV file. And next we have no null values here, all are non-null values. So we have 2 float and 4 object and 1 integer here. So next is shape. So shape is nothing but which calculate the rows and columns. So how it shows us how many rows and how many columns we have here. So total we have 244 rows and 7 columns here. And next, print pd.options display maximum rows, which displays how many maximum rows the csv file is containing. So we have 60 maximum rows is contained by the csv file. And next, dataset describe, which describes the dataset. And next, which is, so this is our frame, this is our total bill, this is a tip, and this is a gender, and this is a smokers, and this is day, and this is time, and this is size. So totally we have 244 rows and 7 columns. And next we move on to plotting. So plotting in Seaborn is nothing but plotting a displot. So displot, which is SNS displot, plot show, we all have here. So when I'm giving here sns.displot 0, 1, 2, 3, 4, which plots me a graph like this. And next, plotting displot without histogram. So now I'm going to print print I'm going to print a graph which is without the histogram. That is, I'm to use a code here which is hist is equal to false. So when the histogram is false, it doesn't use the histogram here. And I'm going to just plot dot show. And next is normal distribution. The normal distribution contains of 3 parameters, which is LOC, scale and size. The LOC is nothing but a mean where the peak of the bell exists. And next is a scale. A scale is nothing but the standard deviation, how flat the graph distribution should be. So how flat the graph distribution should be. And next is size. Size is nothing but the shape of the returned array. So here I have given from numpy import random. I have imported the random here. Next I have given used a variable here as x and random dot normal, which is normal distribution. So and next I'm going to give the size, which is the shape of the returned array, so which is 2 rows and 3 columns, and print x. So we have 2 rows and 3 columns as I mentioned here. So this is a normal distribution. And next is visualization of normal distribution. So now I have imported my matplotlib and Seaborn here. And next sns.displot random.normal. Size I have given as 1000, and I'm not going to use a histogram here. So I have given as false. I need my graph as without an histogram. So I've used false here. And next plot show. So see, this is my visualization of normal distribution. And next will be binomial distribution. So what is a binomial distribution as, which has 3 parameters here. N, which is a number of trails, and next P, which is probability of occurrence of each trail. For example, for a toss of a coin, which is 0.5 each. And next, which is the size, the shape of the returned array. And next I have used an example here which is given 10 trials of a course generate 10 data points. Okay, so from NumPy I have imported the random here. I've used a variable as x and random dot. This is a binomial distribution, so I've used the word binomial here. And next n which is equal to 10, which is the number of trials. I need n which is equal to 10 trials. And next I need occurrence of each trial which is 0.5. And next I need the size is 10. So the returned array is I have 10 numbers here, which is the random numbers here. Okay, so it has given me a random numbers up to 10. Next will be visualization of binomial distribution. So we imported my random, imported the matplotlib and imported the seaborn here. Same I have used here sns.dispplot random.binomial. Here also I'm going to get a random value and n which is equal to 10 trials. The number of occurrence is 0.5 and size which is equal to 1000 and hist which is equal to true. True means the histogram should be present there. And next kd which is equal to kind and the kind should be false here. That is a curve. And next a plot show. So this is the graph here. And next will be difference between binomial and normal distribution. And next I have imported my numpy, random, matplotlib and seaborn as shown previously. And next sns.dispplot I've used random.normal and I've used location which is equal to 50 and scale is equal to 5 and size equal to 1000 and histogram should be false here and label I've used a label as normal here. And next same down I've used n is equal to 10 which is 100 tiles here and number of occurrence is 0.5 and the size is 1000. So the histogram which is equal to false here and label equal to binomial. Now using the plot show have got an graph like this. Next will be Poisson distribution. In Poisson distribution we have lamb and size, that is two parameters. A lamb which is known as a rate or known number of occurrences. For example 2 for above problem. Okay, 2 for above problem and the size is the shape of the return array as we seen earlier. Next, which is visualization of Poisson distribution. So in this I've imported the numpy, matplotlib and seaborn here as we seen previously and sns.dispplot I've used a random.Poisson, so which is a Poisson distribution it is. So Poisson and lamb which is equal to 2 and size is equal to 1000. Lamb is nothing but a rate or known number of occurrences. So our known number of occurrences is 2 here and the size is 1000. So my kind will be false. So the curve should be false here. Only I need the histogram. So next plot show. So I'll get a bar graph here now. So this is the output here. Next will be uniform distribution. We have three parameters here which is a which is equal to lower bound, for example a default of 0.0 value and next b the upper bound, so default of increasing a one value which is 1.0 and next is size the shape of the returned array. So now I've used a problem here which is create a 2 into 3 uniform distribution sample from numpy input random. I've used a variable here which is x and next the random, so that is a uniform distribution. So I'm going to give a random values dot uniform which is size which is equal to 2 rows 3 columns. So as we seen we have 2 rows and 3 columns here and it has thrown me a random numbers here. Next will be visualization of uniform distribution. So here sns.dispplot random.uniform as we said earlier and I've used the size as 1000 here and I do not need the histogram here. So I have given hist which is equal to false and plot is equal to show. So my output will be like this. And next logistic distribution. So we have three parameters here as we seen earlier, LOC which is mean where the peak is default 0. Okay, and next scale. A scale is nothing but standard deviation, the flatness of the distribution, a default 1 for example. And next size, the shape of the returned array. So here I've used example draw 2 into 3 sample from the logistic distribution with the mean at 1 and standard deviation 2.0. So here I've imported the random here, and I've used a variable as x, a random dot logistic, and LOC equal to 1, scale is equal to 2, size is equal to 2 comma 3, and I have printed these x. So now I have got 2 rows and 3 columns as I mentioned here, and my scale will be 2. A scale is nothing but standard deviation, how flat the distribution is. Okay, it might be positive or negative value, and my location is 1. And next is visualization of logistic distribution. I've used sns.dispplot random.logistics, size is equal to 1000, ist is equal to false. I do not need a bar graph here, histogram, so I only get a curve here. So this is the output. And next will be multinomial distribution. So n, which is equal to number of possible outcomes. So we have three parameters here, which is n, p-vals and size. N is nothing but number of possible outcomes. For example, 6 for dice roll. And next p-vals, a list of probabilities of outcomes. For example, if I'm giving 1 by 6, 1 by 6, 1 by 6, 1 by 6 for the dice roll for each outcomes. And next size, the shape of the returned array. So now I've used a simple example here, which is draw out a sample for dice roll. From NumPy, I've imported the random. So x is the variable I've used here, and random dot multinomial, and n, which is a size number of possible outcomes here. So this is 6 outcomes I've given, and the p-vals is 1 by 6, 1 by 6, 1 by 6 I've given for the foremost. I've given 6 values here, the same. So I've got 100113 my output. And next will be exponential distribution. Exponential distribution is nothing but we have three parameters, which includes here just scales and size. Sorry, two parameters, which is scale and size. Scale is nothing but inverse of the rate. So for each distribution, the parameters will change according to the distributions. So in exponential distribution, the scale has been inverted to inverse of the rate. So see Lamb in Poisson distribution defaults to 1.0, which inverts the rate here in exponential distribution, and the size, which is equal to the shape of the return array. So you have used a simple example here, which is draw out a sample for exponential distribution with 2.0 scale with 2 into 3 size, that is 2 rows 3 column size. For I have imported the random and use the x as my variable, and random dot exponential. My inverse rate is 2 and my size is 2 rows 3 columns. So I'm going to print the x. So my foremost answer will be a random number which contains 2 rows and 3 columns. Next, visualization of exponential distribution. So same I've used sns.dispplot random.exponential, size is equal to 1000, and I do not need a bar graph, so which is histogram. So ist is equal to false. I'm to plot the show. So my output will be like this. And next will be chi-square distribution. In chi-square distribution, we have two parameters, that is degree of freedom, that is df, and size, the shape of the returned array. So here we imported the random, x as a variable, and random dot chi-square. Here I have given degree of freedom as 2 and size as 2 comma 3, that is 2 rows and 3 columns. So when I'm printing the x, I get a random number which contains 2 rows and 3 columns. Next will be visualization of chi-square distribution. So here we are going to use sns.dispplot random.chi-square. So df, that is degree of freedom, which is equal to, I'm going to give as 1. And next is size, which is going to be 1000. This is equal to false. That is my bar graph will not appear here. So this is my output. So next, Rayleigh's distribution. Rayleigh distribution contains two parameters, which is nothing but scale and the size. The scale is nothing but standard deviation decides how flat the distribution will be, default 1.0, and size, the shape of the returned array. So now I'm going to import the random. X is equal to random.Rayleigh, scale is equal to 2, size is equal to 2 comma 3. So print x. So I've got 2 rows and 3 columns here are random numbers. Next, visualization of Rayleigh distribution. I have used a random Rayleigh size, which is equal to 1000, and I do not need a bar graph here. So I have given this is equal to false. So this will be my current output. Next will be Pareto distribution, which is A, which is equal to shape parameter, and size, which is equal to shape of the returned array. Here I'm going to use the shape parameter. So the shape parameter will be 2 and size will be 2 rows 3 columns. I'm going to print x. So I've got a random number with the size of 2 and column is equal to 3. Visualization of Pareto distribution. I've imported the random, import matplotlib pyplot as plot, import cborn as SNS. I've used sns.diskplot random.pareto. That is my shaped parameter, which is equal to 2 and size is 1000 and kind is equal to false, which is I do not get a curve here. So my answer would be like this. And the final distribution will be zipf distribution. We have two parameters, and in zipf distribution the a will be distribution parameter, not will be the shape parameter, and the size will be shape of the return array. I've used a example here, that is draw out a sample for zipf distribution with distribution parameter 2 with size 2 into 3. From numpy import random, x is equal to random zipf, a is equal to size with 2 rows and 3 columns. So printing x, which we get a random number of 2 rows and 3 columns, which is 1 to 10 and 112. So now I am going to visualize the zipf distribution. That is, I've used a variable as x, random.zipf, a is equal to 2, size equal to 1000, and sns.diskplot x, which is lesser than 10 and kind is equal to false. I do not get a curve here. So my output will be like this. Thank you.